Hello. After we talk about the lab on our previous lab talk about how to install the MongoDB, and also give you some example before we talk about the secure communication. And today, just like say recap, like in the lecture about like how we are able to secure our communication for the smart devices in IoT. Okay, so for the whole structure, so we'll know like how we can including the devices and the endpoints, including the sensors and accurator or some embedded system, all these. And we are trying to communicating through different networks, including the Wi-Fi or connect with the Bluetooth and ZB or cellular, all these etc. Or even physical internet. So for the also and the cloud and server infrastructure, so including the backend server and then the cloud platform, so they will store our data. So like right now, and also perform some processing power, right? Including so when we in our lab we try to demonstrate in like using the API server and storing the data using the MongoDB. And for the hardware right now for testing, maybe you connect your Raspberry Pi to your local internet, maybe through Wi-Fi or like directly using the Ethernet cable, or if you have some devices, maybe you're allowed to use connect with the Bluetooth. So it depends on you. And then the overall connection in the security. So we like mentioned for the device security, include like they were more likely would be the physical and firmware security. And we talk about like to keep we need to always regular update. And here is the issue because after we install it, actually it's barely update the firmware. Okay, so like really physically or change the hardware. And most of the time when we learning what we do, like maybe on the network security, so we try to protect the data in transit. So that means that we try to in the previous lab, or like even the assignment are asking you try to using the TLS SSL like to encrypt data, so like have protect it. Okay, and then for the cloud server, so we will try to protect data at rest. That means it's secure at rest, like storage and ensure the access control. That's like our target trying to do. And when we try to secure the communication in IoT, like what's the final goal? Of course, like CIA, when we like talk about CIA confidentiality, so we try to prevent some unauthorized parties from accessing the sensitive data. So you see, even for the secure communication, we just explain the idea from the cyber security. So for integrity, so we try to ensure the data they have not been like tampering with during the transmission. And for the authentication, we need to verify the identity of the communication devices and user. And in our assignment or lab, I ask you to do so. We need to create your own certificate. Okay, we try to use the SSL right for authentication and all this. And one more idea we try to introduce is non-replication. So we try to ensure the party cannot deny the action it performed in the communication. So these are one more like try to secure. And we always ask a question like why encryption is matter. So encryption essential, we try to ensure the confidentiality, integrity of data exchange between the IoT devices and then the networks. So that's what we need to do it. And then for the IoT environments, typically we will involve like various communication protocol. And since we have different protocols, then when we need to secure and protect the communication, then we need to have different techniques, the encryption technique adapt to these different protocols. One of the protocol we are using is TLS SSL. Okay, so that's like we're doing in the lab. So like I think you do in the assignment. So TLS is representing like is the transport layer security. So it's a modern protocol used to secure the communication on the internet. So it will encrypt the data and provide some authentications between the client and the server. So we know like who are who, okay, who they are. And then the SSL, the secure sockets layer, okay. So this one, the predecessor of the TLS, but it's now like depreciating. So because like TLS is more secure and also widely used today. When we say it comes together, we have the TLS or SSL. So, but we are like doing this. TLS, we can ensure the confidentiality, integrity, and for the authentication of the communication. So that's why I say it's more. And but every time we just like put them together, okay. And for this protocols, how it works like TLS, so it includes the first step, like we try to establish the secure connection setting, the cipher series or keys, including this, and then we try to get the session keys. So we generate during the handshake to encrypt the data. So for the three-way handshaking, so we try to like say hello, hello, be right back, and they say okay, I'm going to start sending. So during the handshake, then we will share the generate the session key. Okay. So for the message authentication, so we try to ensure data have not been like tampered with. So protocol, like one thing is like for IoT specific concern. Okay. Because like in nowadays we did use a lot the TLS and SSL. So it should be like pretty familiar, like pretty common. But on the IoT, when we try to introduce, like for one thing is about the overhead, because the IoT introduces a computational overhead due to the encryption. Okay. So it can be like challenging for devices with the limited resources. If we have some like small sensors or some low power devices. So that's what we concern like in the previous lab cryptography introduced idea. So overhead is the idea, also bandwidth. So TLS will increase the data transfer time and requires more bandwidth. So it will be the challenge, like especially for low bandwidth network, or we have to will we increase the data transfer time? That means like, okay, if we have a sensor and then we have to like keep on submitting the data back to the server side, okay, then we need to concern it, okay. And also the session resumption. So in IoT, so we need to always keep the connection alive for long periods. So it can reduce the overhead. So the techniques like the session resumption are used, okay. But we need to keep on sending. So you don't want to build maybe our day life. Sometimes we just stay for short period. So the section may be expired. But if for the IoT related, then we have to always like keep it alive. Then how can we make it? So this is called the resumption. And pretty common, maybe we will try to use it for secure the HTTP access with TLS. So they may be the famous sending the encrypted HTTP request to the web server, so we can use the HTTPS. So this one over TLS. Okay. And there's some, and another one is called the datagram TLS. So it's the with D. So datagram is the protocol. So the protocol like designed for secure the datagram based protocol. So such like is the UDP. So the user datagram protocol, we say like, so it will be like what you use for real-time application, voice or video. And compare with the TLS, DTLS, so it's like while the TLS is for stream-based protocol, like the TCP, and then the DTLS will be like optimized for the package-based communication, UDP. So here will be like the difference between it. And when we use the UDP, maybe they prefer IoT because some like low latency and simplicity. However, because one thing is like UDP compared with the TCP, it lacks reliability. So it's possible losing some certain package. Okay, so we are not really need require like for the UDP. So we need to like for the secure the communication with the encryption and also authenticate, right? So that's why it comes out the DTLS. Okay, and maybe depends on some situation. If we're sending data is okay that we can meet certain package that we can use in EDP. And why is important because we try to like ensure the security and without like sacrificing the low latency performance of the UDP. So even though we talk about the TCP, UDP, but also we need to like ensure the communication. So we introduce them. So pretty common in real life application, IoT, so smart home devices, like some gaming devices, all this, we are using it. So something like smart light system. So because for the light system, then we can use the UDP communication. So for security, then we can use the DTL. So it will be like secure the real-time command line to switch on. So it will be like this smart device to the gateway and to the cloud server like this. So another one is called the AES. So AES called Advanced Encryption Standard. So it's a symmetric key. Okay, so it will be the encryption algorithm. So using to secure data, and AES is like prefer over the asymmetric algorithm like RSA in IoT because it's efficiency and speed. Compared with the RSA, because RSA is asymmetric, right? But you know, for the complexity time consuming, of course, that means that we do provide some encryption, but it's okay. It's like good enough. So we use the symmetric key. So we share the key. Why is more like suitable? Like first thing is that we can operate it quickly. Okay. So if we have limited resources like processing power, low power, so low consumption, then we can use AES. And also AES can give a really highly secure and widely regarding as just one of most secure encryption algorithm available, you know. And we can have a different key size. We may be using 128, 192, or 256 bit key length. So if you think, okay, this one have less, even the most less, then we can use 128. If things able, we can go up slightly higher, maybe like 256. So it's okay. And we can use it to like encrypt some sensitive data stored on the devices or somewhere transmitted over the network. Okay. And as what we say when we compare with the RSA, because it's slower, because the complexity of the asymmetric encryption. And just as it makes like, okay, if compared with it, here we need to learn like trade-off, like in cybersecurity and thinking, okay, of course, if we have the cost effectiveness, the result base. So of course, AES giving us a better choice because we need encryption and also we want to like encrypt it and decrypt it quickly. So that's why it's better option. And we can use that protect maybe some like thermostat for transferring the temperature, some certain schedule on the devices and then send it to the cloud. So it's like this through the channels. And also we have some like authentication and authorization mechanism. Okay, so we talk about it for the authentication. So we verify the identity of the user and device. But for the authorization, it's trying to get the granting the permission to access certain specific resources or like we are allowed. So the action after authentication. So first I need to check who you are. So if I know who you are, then we can apply the called the IAM. So the apply permission. Like okay, what kind of resources if you are certain account? Let's say if we are just maybe the devices account or you are the admin or regular user, okay, of course they have different right. Maybe you're allowed to read the data. If you belong to the admin groups, you're allowed to modify, okay? Or if you have the like the highest admin, then you're allowed to modify, read, write, execute. You are the owner like this. And sometimes you will see the offline like 2.0. So what is this one? This one is called the open standard for the authorization. Okay, so we pretty use it commonly for the securing the API access. Okay, so it can allow some third-party servers to exchange the token to authentication the user. So without like needing to share the sensitive credentials, including their usernames and password. So it's the idea we introduced this one. So how it works? So for the authorization code, like including, so like we can use like from the server side for the IoT application. So if we have the system need to connect to the cloud system, then we need to look, okay, who you are. And for the client side, so maybe we use a server to server communication. So they maybe need to get the authentication using some kind ID, some secret. So you see some of you have a secret key like this and an implicit flow. So maybe just like using the same single page app SPA. So or like browser-based IoT system. So also we can use it. Maybe sometimes we see the smart speaker, so we can use the OAuth, so to authenticate with the cloud service, maybe a Google Assistant, Alexa, so they are not required you to store your user credentials locally. So they will ask like for one time, and then how it works, like maybe getting your key. And sometimes if you did use Alexa or like Google Nest, then you know like how can you get granted permission, like you sign account and do it, so they would able to get it. And then the next one, like we show in our lab, or like when we try to implement like on our Express.js. So later, how can we secure it? It's called the JSON Web Token, JWT. So it's a compact URL safe method, where we sending like to claim between like two parties. Okay, so it always like contains a header. So it's like used for the like algorithm, and then the payload, so it will be the claims and the signature. So we need to use it for the verify the authentication. So use it so they're working together. So for the workflow, including like first from a client, that means the IoT device, they will want to like require the access to the server, right? So the server will try to authenticate, like if the devices, so they will return a JWT contain the claim. Okay, the device ID, permissions. So the client, that means the device, the IoT device, can use this JWT for the subsequent request to the authenticate itself. So you can use this one to sending like connect to the API. And because for the simulation and for the lab for a project, so that's what you need to use. And I already give you the sample code, because maybe in the previous, I only telling you to construct and prepare for it. And later, after if you're ready, suppose after this week, we cover the MongoDB, then you should able like, of course, I will go into the details. How can you implement the first like set the habit of your Raspberry Pi, then how can you secure it? Okay, setting a habit using a JWT, and that's what will be your next task. So when we use it for like, it will be more like a token-based authentication, so we can like secure the transmission. So we will see like no matter the TSL using certificate or JWT, the OAuth, so they are all like using kind of same idea, token-based key, secret key. So use it for big communication, like transmits the data between devices and servers. And that's like how we use like maybe you have the wearable IoT device. It's kind of like maybe your Apple Watch, maybe like smart like fitness band. Okay, like this. So we can use the JWT tokens. So it can get the authenticate API request, then send it to the some like have monitor platform. So it's possible we can do it in this way. And here will be what we like in the cybersecurity, we talk about that, and it's called a role-based access control, RBAC. So RBAC, so it's the policy restrict the system access based like, on the user role, and IoT too. So we can use it to control which device or user can access specific resource. especially we have like multiple smart things, like different IoT devices and sensors, gateways. So we need to assign, okay, so they have different role, and then we can define which action they can perform. Maybe in between we have different gateways and we have different nodes. So if we have a smart home system, so thermostat maybe only allowed to access the temperature data, and if for camera, only for camera, but for the maybe as a whole, you are the admin of the home system or user of the whole system, you should able to access both of them. Okay, and for the admin, you may be allowed to like add the modify. For user, maybe you're allowed to read it. Okay, but for the lower some devices, they're not allowed to like cross check each other's. So here's will be the we call the role-based access control. And for the IoT network security, like for the network architecture, once is called the mesh network. Okay, so they will communicate with each other directly. So it will improve the reliability, but they need to because they will process security measure. And for the star network, so it's more like the star they connect. So there we have a central hub-based network with the device, and then we connect to a central server or gateway. So we have two different networks, mesh and star. If we want to like secure, sometimes we're using a VPNs or IPsec to encrypt the network traffic. So maybe we need to sending the data over the internet, and we maybe set up the VPN connect to the cloud platform like this. Then we instead of like saying public, then we try to set up the virtual private network, and then we can send it. So it's one of the possible way. And when we like knowing the internet architecture protection, what are the common attacks happen in the IoT networks, including the man in the middle. So they try to intercept data between devices, or DOS, try to overloading the devices or maybe a server, try to cause the failure. Okay, so if they most of them maybe they will DOS your gateway or your server, your platform, so you cannot send it to your server. So make it the surface down. And when we mention about the gateways, or we talk about gateway, we will be acting as the intermediate between the IT devices and the cloud, right? So they will like aggregate and transmit the data. Also, they provide some security function, including like encryption, firewall. You can imagine kind of one example gateway can be your router. Okay, if you put it in certain location. Of course, like in a company, they maybe still have a router and another router. There are different levels of routers setting up. And also we have the edge computing. So edge computing, including like they will edge devices, including they perform computation, data processing. So they will like closer and then to where the data is generated. So his idea to reduce the latency and bandwidth use. We did mention about the edge computing. So you can treat like Raspberry Pi, like receive the data, okay, or the sensor every second, right? Okay, every nanosecond too, and then we try to like compute it and try to like process the data. After that, we send it to our cloud server. So in this the edge devices, also we need to like maybe set up the firewalls, and then the intrusions like detection system or the secure boot mechanism to ensure the integrity of the devices. So that's what we need to do. And here will be the what we're going to use one of example in a lab. So it's the mosquito. So we try to use the mosquito communication. So this one I will go through one more time. So you can either using Node.js or Python. So where you and then you will use the open access to generate the certificate. Of course, we need to like set up mosquito MQTT Broker, and next we need to create the certificate. So we are using for the server and client. So this kind will be your Raspberry Pi. And we try to configure the MQTT Broker and then the client to use the TLS. And then we can try to test it with the communication. And for the instruction I really set up. So after set up and then create the SSL and then after configure it, and then we can like try to sending it and workplace. And so far will be like this. We are just cover like telling why we need to use like encryption, authentication, and how can we secure the network. We're using and those techniques include the TLS and then for the UDP DTS, and then of course we use the AS instead of using the asymmetric way. And also for the devices we were using some token different way like JWT, the OAuth, and for the different assets we're using the role based. And in the real world, like in the industry, actually when we try to implement this different method, we always like have a constraints, like resources constraint, because maybe the processing power, bandwidth, or the depends on the location. So we try to increase the security, and because the the numbers like getting more, but we need to of course protect all the system, including the cloud, the gateway, and then the end computing. Okay, and that's it for the lecture part, and thank you.